Now do a couple of these examples. Describe how the graphs of the following functions relate to the graph of x squared. Now I'm going to do B and C. I think this one you should be able to handle. But this one here, we have a vertical translation, and if it's positive 4, that means we're going 4 units up. Y plus 8 is equal to x minus 5 squared. Now we haven't seen something like this yet. So all we got to do is set this equal to y, and in order to do that, I got to subtract 8 from both sides of this equation. So this becomes y is equal to x minus 5 squared. Instead of plus 8, we have minus 8. This results in a horizontal translation right here, 5 units to the right, in the positive direction, even though that number is negative, and a vertical translation, 8 units down, because that's a negative 8. Next, the following transformations are applied to the graph of y is equal to x squared. We want to write the equation of the image function for each. So 2 different cases. If we have y equals x squared, 5 units to the right, that means what we're doing, if y is equal to f of x, or y is equal to x squared, then if we're moving that to the right, then this becomes x minus 5 squared. With this next problem, we have a translation of 6 units down, so we know that our q value is going to be negative 6, and 4 units to the left. So we have x positive 4 squared minus 6. And lastly, write the coordinates of the image of the point 3 and 9 on the graph of y equals x squared when a translation of 2 units up and 7 units right is applied. So if I'm starting at these coordinates, 3 and 9, my first thing is I have a vertical translation of 2 units up. So if I go up, then from 3 and 9 by 2 units is going to go to 3. 9 plus 2 is 11. All right, so we went 2 units up plus 2. But we're also doing 7 units to the right. And so from 3, it's moving in a positive direction. So 7 units, we're going to add 7, but only to the 3. So we'll have 10 and 11.